All right, good morning class and welcome back to Math 11. Today our learning target is again involved in trig. We're going to be looking at the second function in trig or second operation we refer to as sine. So remember SOHCAHTOA, a little acronym for remembering it. The S stands for sine, the C is for cosine, and the T is for tangent. And the O, of course, refers to the opposite side. The H is the hypotenuse. A is the adjacent side. H is the hypotenuse. O is opposite side. And the A is adjacent. So little memory aids to help you remember which function to use. So we're going to be looking at setting up a scenario, making a diagram for a particular problem, and then going through an operation. And just before we do that, I just want to review when we want to solve some problems. Say we had tangent. We're working last class. Say we had an angle of 25 degrees. So if I had something like this, and there was my 25 degrees, I was looking, say, for my opposite side. This is my opposite side. I wasn't given it, but they told me my hypotenuse, say, is 10. And I want to know how big is my opposite side. So I would set that up as tan 25 degrees. And remember, tan is opposite over adjacent. So I need to have a side there. Now the hypotenuse is not important to me for tangent, so I don't need to consider that. But I need to have at least one of these two sides. Opposite, I don't know. Adjacent is 7. Opposite, I don't know. Adjacent is 7. Okay, so when we have this, remember, it's like setting up a proportional statement. Tan of 25 is equal to x over 7. Anytime you have a number, a degree, anything can be over 1. Doesn't change the value. So now we have a proportional statement, so I can cross multiply. So that's 1 times x is x equals tan 25 times 7. And then we just put that into our calculator and we get the answer. But sometimes we have a situation, maybe I'll put that in different colors so you can see it. Remember I had 10 here, there's my right angle, there's 25 degrees. But instead of having the unknown here, say I know this here is 5, but this time I don't know what the adjacent side is. So I set this up again. Tan is equal to my opposite side over my adjacent, O over A. My opposite side is 5, but my adjacent side now, it's on the bottom. The unknown's on the bottom. Well, here's a little trick. That's our equation. Remember, anything like that can be put over 1. Whenever you have the unknown on the bottom of the fraction, just switch it. I'm going to switch places with that, which means I'm going to put my x up here, and I'm going to put my tan on the bottom here. So I still have 5 at the top, but now I put my tan on the bottom. So I just switched places here. Put the x up here and the tan down there. So now, instead of multiplying 10 by 25, I'm dividing 5 by 10, 25. That's going to give you the correct answer. Okay? So whenever your unknown's on the top, when your unknown's on the top, you would multiply. When your unknown's on the bottom, you would divide. Okay? It's just a little thing you can remember. All right? Any questions? When I divide, I would put 5 into my calculator. And depending if your calculator needs to put the degree in first or the tan, and I don't know. Calculators are different. Mine, I just put in 5 divided by, and I hit tan 25. Some other calculators, you have to put 25 degrees first, then hit tan. One thing about calculators is that if there's multiple operations, they only do it, they can't think ahead like our brain does. So it's best to use brackets. So whenever I use the calculator, like I'll show an example here. Here I want to divide 5. It's got to be divided by tan 25. Now in this case here, I'm going to try putting tan first. See, it went for 5, made the tan of 5, not tan 25. So I don't want the tan of 5. So I'm going to put my 5 in again, divided by, and I need to put a bracket. Okay? Put the bracket, and then I'm going to hit 25. Then I hit tan. It changed my tan 25 to that decimal fraction. I close the bracket and hit equals. And there's my answer. My answer would be 10, 10.8, 10.7. So the point is, when you're dividing on calculators, when you're dividing something, begin by putting in a bracket, put in your number, then close it with your bracket. Okay? So the calculator knows what to do. Just look at another example. Just say I have to use x is equal to, say, 10 divided by the tan of 60. Okay? Say that was my operation. Go back to my calculator. I put in 10 divided by, now first things, put in my bracket. I got to do the tan of 60 degrees. So I'm going to put in 60. And then I'm going to tell the calculator to calculate the tan of 60 degrees. So then I go hit my tan. It calculates right away. It puts in the decimal, 1.73. I have to close that bracket. And then I hit equals. And there's my answer, 5.8. Okay? All right. Let's clear that. Now, let's move on to sine. These are signs, not the same thing as a sine trig. But you look at the signs. These are warning signs. What are they telling you to do there? What is that person wearing? Glasses. It's telling you you need sunglasses. Could be very bright. Or it could be safety glasses. Here it's telling you to wear what? A hard hat. Here it's fingers in your ears. What is that telling you? You need ear protection. There's loud noises, right? Here it's telling you that there's low hanging. You watch your top of your head. Deer crossing. Wolves. This is looks like fish, right?
No, I think someone come down and say so about people getting lumber.
Okay. This is look like maybe lumber in the river then, or it could be logging, right? Logging? You say it looked like it's a tree there? It's a very falling trees. Good one. Watch out for falling trees. This is UV radiation. I'm not sure where that is. Yeah, look out for the sleeping person. This is a wheelchair ramp, and of course, probably wet paint. You'll see that sometimes. So these are all warning signs, different types of warning signs. Sometimes there's some funny ones. When I was traveling through Scotland, they had a warning sign with a picture of a mammoth. You know those elephant type beings with the big husk of the woolly mammoth? Well, they're extinct now, they're gone. But someone put up a sign in northern Scotland that said, beware of woolly mammoths. I think it was a joke. You know? Sometimes people put that. Okay, so here's a warning sign, and it tells you that there is a hill. And the car to go down the hill will have a grade of 12%. So it's warning you before you go there to slow down, and for big trucks especially, to gear down. It means that rather than having to push their brake all the time, if they have a big load of lumber behind them, the brake, they're so heavy the brakes will burn out. So they tell them to gear down, put it in first gear, so that the transmission slows the truck down and they can go down the hill slowly. Especially if there's corners on the hill, you may not make the corner. If you ever go down to Mount Carleton, or not Mount Carleton, to Carleton on Quebec side, go up to Mount St. Joseph, it's a winding hill that goes up quite high, and they warn you to slow down because you won't make the corners. And if you go too fast and use your brakes could burn out. There they actually tell you how far the grade is. Now 13%, remember, percent is of 100. 13% is the same as 13 over 100. It means that for every 100 feet horizontal, there is a height difference of 13 feet. Goes up vertically or down vertically 13 feet. That's what the percent means. So if you were up here, it means that once you travel this horizontal distance of 100 feet, you have gone down a vertical distance of 13. Okay? So the higher the number, the steeper the hill. The higher the number, the steeper the hill. Good question. Let's go back. How much is 290 yards in feet? Well, we're going to use that when we get to our unit on measurement, which is later in this course. We'll find out that 1 yard is equal to 3 feet. It's an imperial measurement. So 270 yards, we multiply by 3 feet. That's going to be 810 feet. 810 feet. Now we think in metric, so we'd have to convert that into meters as well. And to do that in meters, we need to have to divide by 3.28 feet in 1 meter, and they'll tell us how many meters it is. Well, we'll get to that later, okay? But for now, to answer your question, 270 yards is 810 feet. No, they. This here.
Yeah, but I'm talking about like for the pit level, that's for 290 yards.
Yeah. What? No, what it means is that this part of the hill is 270 yards or 810 feet. Okay? But it dropped down, we'd have to calculate what that vertical distance is and what this horizontal. They're saying that the grade is 13%. It drops 13 feet for every 100 feet. Okay. No, it doesn't work like that. Doesn't mean that this is going to be 2,400 feet vertical. No. The distance along the road, the hypotenuse is 810 feet. Okay? But this here could be maybe, I don't know, say 700. I'm not sure exactly. And this one could be like 20 feet. This one could be like 20. It could be, you know, maybe more realistic. It could be something like 40 feet and maybe 700 feet like that. and 810 feet going down. I don't know the exact numbers, but that would give you something like that sort of ratio. Yeah. All right, let's get to sine. Now, we're going to have a situation here where a person puts a ladder against the side of a house and is placed at an angle of 75 degrees to the ground. So that means that right here, the ladder, this is the ladder, leaning against the house, it makes an angle of 75 degrees with the ground. And the rule is that if you have it at 1 to 4 rule, it's safe. Elijah has a 16-foot ladder. So the length of this ladder, this red line here, is 16 feet. He wants to use it to repair a window on the second-story window floor. So up here, there's a window that he has to fix. How high can the ladder reach when used safely? Express your answer to the nearest foot. Nearest foot. So first thing is we draw this diagram. Make it look like there's the ladder, there's the angle, there's the house. And they want to write down, they want us to know, can you get up there safely? Well, first thing we need to know, or first thing we need to do is write down what we know. We know the angle is 75. We know the length of the ladder is 16. And what do we need to find out? We want to know the height the ladder can reach. So this is what we need to know, is how high this can go up. So there's our unknown, the height. How far up can that ladder reach? So we need to know this part of the triangle here. So what we have is we have one angle and we have one measurement. We can use trig. First thing we do is label that triangle. If this is the reference angle, then this side is opposite. This is my right angle, so this side over here is my hypotenuse. It's opposite the right angle, which means that this side down here is my adjacent side. So they want to know what x is. They want to know what the opposite side is. The side they've given me is the hypotenuse. That's h. So if I look at my trig ratios, so Toa, the one that has an O and H in it, this is OA, OA, AH, OH. It's sine. So I have to use sine this time, not tangent. So this is a sine problem. So I write that down. Sine of whatever angle they give me is the opposite of hypotenuse. That's O over H. The angle they give me is 75 degrees. The opposite side is the one I don't know. That's the height. So we put an X. Remember? The opposite side is X. We don't know what that is. Whoops. And we know that the hypotenuse, the length of the ladder, is 16. So now we have an equation that we can use to solve for X. So when we have that, remember, it's the same thing as over 1. So now we cross multiply. X times 1, it's X. Sine 75 times 16. Sine 75 times 16. We put that into our calculator. I'll just show you that one right here. Sine 75. Now in this calculator here, we have to put the degree in first. So 75 sine, here's your sine button, there's our decimal fraction, times 16 equals. We get 15.4548, this long number, 15.4548. So then we're going to round off. This is 4, so we can leave it as 15 feet. If it was a 5 here, we go to 16. So the height above the ground that the ladder can reach is 15 feet. All right? So that unknown up here this value here now, we calculate it to be 15 feet. The 16-foot ladder can reach up 15 feet on the wall. And like all of these questions, once I solve it, I write it down in a statement. The ladder can reach safely a height of about 15 feet. All right? Any questions? All right, so here we look at another one, and I'll set it up with you again. Elijah borrows an 18-foot ladder. Now he's got a bigger ladder. How high can this ladder reach when used safely? Express your answer to the nearest foot. Oops, sorry. I'm trying to raise this. There we go. Okay, this time he has 18 feet for a ladder. This is the right angle. Here's my house. To meet safely, we have to use an angle of 75 degrees. So we're trying to find out how high up we can go. How high up? So that's where we're trying to find out, that length there, that height. So we have the angle, we have a side. We look at what is this side over here. That's our opposite side. This side here, opposite the right angle, is my hypotenuse. And the last slide is adjacent. Since I am looking for opposite, and I'm given hypotenuse, means I have to use sine. So sine of 75 degrees is equal to x over, and this time it's 18. Remember, this is to be over 1, doesn't change the value. I cross multiply. 1 times x is x. Sine 75 times 18. That's 18 feet. Put our units. Go to our calculator. Just going to clear it. Okay, so 75 degrees sine. That's my sine fraction there. Multiply it by 18 equals. And I got 17.38666. And a whole bunch of numbers after. Since this is in the whole number already, 18, I'm going to round that off to, since this is 3, I can leave it at 17 feet. So the ladder can reach a height of 17 feet safely. Of about. We know that there's a fraction there. I'll just put about, but that's the closest number. Okay. If you wanted to, you could round it to one place. Sometimes you may have to, because you don't want to have the same number as this. So I could round this off as 17 point. I'll just go to one place, 4. Here we write that. Way down. 17.4, and I will accept that answer too. Unless I said whole number, you can leave it as one place after the decimal, 17.4. Okay? All right, so that's it for examples. Your math assignment for today, make sure you label it as assignment 2C, so that I know that it is different from the one you did the other day. So this is going to be Math 11, assignment 2C. Put your name on there. giving a copy of these pages. You're only going to do 1B, 2A, 2B, 3A, 6, and 7. And then there's an extra practice sheet here, and only these particular numbers. This is the same practice sheet I gave you the other day. And I'll show you right now again. There's the page numbers. That's page 315. And this is page 316. And then the extra practice which I gave, you did some tangent, but today you're going to be working with the sines. So there is, and I forget which number I told you on those, 4 and 8. So we go back here. So you're going to be doing question 4. We'll be doing the A, B, C, D. And then question 8. All right? So those things are in your pickup box for the people here at the TC, and for the people at home, you have them here on your video lesson, and I also send a PDF copy of those. Thank you. That's it for today.